Hey, can you still fight?
What? What kind of question is that? There's nothing you can do to stop me!
Okay, we're going to begin by launching the program and logging in. This particular version of Matrix Encryption uses a GUI. It's not yet available on our web app, but it will soon be there. We're going to use codex 90 and we'll activate our personal codex rather than using the custom codex option. And then we want to encrypt a file. We're going to use this 10,000 character message. It's an excerpt from Immanuel Kant, the German philosopher, and here he is talking about a priori and a posteriori knowledge. Thought it would be sufficient. Okay, so let's click encrypt. We'll use the Sapphire master key. The encryption is complete. See, encryptions don't take very long. It's the decryptions that can take longer. We will save the encrypted data to 10,000E and then go in the associated folder to that file. Resort, and there it is. 10,000E contains a 20,001 digit integer that is the encrypted data, the encrypted data. Not 2,000, 20,001 digits. We had spillover that was handled by FCM, full codex mastery. Now we're launching the decryption program. We need to log in. If I can type. Get nervous sometimes. Codex 90. And let's try a codex that we know is wrong. We're going to use the Spinel codex. And we don't have to see it, just take my word for it that it is a 90 character text file with unique characters, and they're in a different order than the Sapphire codex because the order matters with permutations. If it was combinations, there would be only one codex, but the order matters, so we permute the codex space when we use any unique codex out of the permutation of 94, pick 90 in this case. And here we have used the Sapphire Master Key 2, which again, just take my word for it, it's a different key. We're using the wrong key and the wrong codex. Are we going to recover the data? You tell me. Actually, don't tell me, just wait and see. We're gonna look at it together here very shortly. Decryption in progress. Okay, decryption complete. See, this doesn't take very long. We saved it to 10,000F for failed or false. 10,000F is the wrongly decrypted data of the text file 10,000 containing that excerpt from Immanuel Kant. Let's return to options, Plaintext service, codex 90.
Now that was a close call.
And We could use personal codex, which is the Sapphire codex, but if we use the custom codex option and just type in Sapphire, we activate the codex. Another way, I designed this program to be very versatile, and we need to try and decrypt 10,000E. We're using the correct codex, and now we're going to also use the correct key.
Who does this fool think he's dealing with?
Upload it as a custom key.
Show him. I'll show them all. I'll reduce this place to ashes.
Just to prove a point. And decryption in progress, please hold.
Father, let me help. You're not strong enough.
Don't make me tell you twice.
Really? The strongest man in the world? Ugh. Do you think you could take me to him? I want to fight him.
Decryption complete.
Just wait. I can't be hard to destroy than a planet.
And it should have decrypted correctly. Let's see. 10,000D.
You haven't
Save.
figured it out yet.
Resort the associated folder. We're going to highlight 10,000 and 10,000D and open them at the same time and look at them side by side.
You have to. They'll get you killed.
This is bad. He has us standing here drunk. We have to help him. But how? It's too soon.
Okay, the contents are identical except for the very last character, which is something that can happen with Codex 90. But we used padding before and after, as you can see, so no relevant data was lost. Okay, none whatsoever. Now, here comes a special treat. We're going to turn on a print one particular line in the inverse program that will give us a surprise. Quite a surprise. As we saw, the decryption of 20,000 digits takes like 30-45 seconds with this setup here. But if we turn on just one print of part of the calculation for decrypting the data, my goodness. We're about to find out where Matrix Encryption gets its name. And it relates directly not to the Matrix movie per se, but to the Matrix Rain. The Matrix Rain, the digital rain from the Matrix. And you can imagine my surprise when I saw this the first time. I thought something was wrong, but nope. Every single digit here is necessary. It's not necessary to print this to the screen, but for the sake of demonstration, this shows the vastness of the calculation that's actually happening.
But this is going to be the last time.
Enjoy.
Destroy reason. He made me what I am. Don't let him do it. Just anyone else. Whatever it takes. Stop it. Behind my father's
Again, every single digit that you're seeing on the screen is necessary in the decryption calculation. We don't have to show them, but when we show them, it really shows what we have done, what we have accomplished. And that is nothing less than the conquering of a subset of the rational number set, the set of rational numbers, n over 9, and the floating identity that makes this possible. Yes, we have overcome floating point decimal rounding error. That's essentially universal for all fractions calculated in a computer. They're all rounded. They're all rounded. It's similar to how 1/3 is 0.3 repeating, but that has to be rounded in a computer or in any display, because you can't have an infinite number of digits. It would take up an infinite amount of storage. And it just so happens that in binary, even rational numbers that are finite in their decimal expansions end up being infinitely long in binary base 2, and they have to be rounded. But I found a number theoretic way around a scaling solution in number theory that allowed me to salvage the CBD functions that we will show you here briefly, momentarily.
Be aggressive. Take action now. Two men agree to have a duel with each other. No matter what the outcome is, they have to accept it. The first step you need to take is just that. Step. Any type of danger, right, gives you this fight or fight response. So train. Starts with training. You know, it's kind of a way to achieve power. And even when bad things are happening, you know, standing stoically saying, okay, let me take another look at that and I'll get it done.
There's the floating identity. Oops.
You've had enough.
There it is.
Suffered so much from my foolish dream. Forgive me. I did what I wanted until the end.
You've given it your best shot. You can stand down. You can back off. You can rest.
There are the CBD functions, and you see the term over 9. The floating identity allows us to divide by 9 in base 10, while only dividing the sum of digits of the number by 9, which is a solution that can be recursed or otherwise done recursively, aka recursion, in order to achieve full fidelity. The recursed floating identity is able to extract the entire whole part of n over 9 for any arbitrarily long number, any length number. A GUI in length, if you like, any length.
You're losing control. It's not strength, it's weakness.
You must unlearn what you have learned.
Those who can eat the most.
I sure was hungry.
He just ate 57 full-course meals.
Really? I lost track around 40.
Don't worry, it's going to pull through. Sorry about that. Yeah, n over 9 is equal to sigma of the floor of n over 10 with the index running from 1 up to the length of n minus 1 plus sigma of the floor of n over 10 to the I times mod 10 with the index running from 0 up to the length of n minus 1 over 9. That can be recursed, resulting in limitless information fidelity.
This was the first time I could use my absolute strength, and you answered. It was the only way it could end.
When we recurse the floating identity down to the digital root, it gives us limitless information fidelity and the ability to extract the entire whole part of n. Only the digital root, which is a single digit, is divided by 9 when the floating identity is recursed all the way down to the digital root. We don't yet have the recursed floating identity coded, but we don't need it yet, because the ceiling afforded by just this first iteration is quite high, and in our patent it was calculated to be on the order of I think it was like half a petabyte. We're almost done. Decryption. The decryption is finally finished. And we save over 10,000D, even though we had already created that file. It was just written over here, and now we can look at it with 10,000 beside it. And see that again the last character is different, but no relevant data, which is the data in the middle, sandwiched in between the gibberish, was protected and unaffected. This can...
I'm still alive. I'm still here, alive. I should have died. Somehow my body just... I crossed the line.